Hello everyone. Today we're going to be going over the 6-7 notes. These notes will go over how to graph circles on a graph. Now, when we're doing this, we have two possible equations, but really only one of them are the more important one. This one over here is a universal equation we use in all situations. The second one is a more specific one that only happens whenever the center is located at the origin. So, let's go ahead and learn the more universal one first, and then we can derive the second one. Over here, if I've got my center located at h, k, h being the x value of the center and k being the y value of the center, then I can use this equation to make a circle. X minus h squared plus y minus k squared equals the radius squared. Again, h and k are the x value and y value of the center. R is the radius. Now this is what we call standard form. And like I said, this is applicable in all scenarios when we're trying to graph a circle. What we're going to do is we're going to use this equation to try and find out what this equation should be. Over here, it says when the center is located at the origin, which we should know is located at 0, 0. So what I'm going to do is I'm going to call this my h value and this my k value, plug it in, and see what I get as a result. Looking at this equation, I'm going to say x minus the h value is 0 squared plus y minus the k value is 0 squared equals the radius squared. I just brought over everything from over here to over here. Now, what we're going to do is these zeros are important. These lead us to what the equation should look like. Let me ask you, if I had something like 5 minus 0, is there any point in me writing the minus 0 part? No, there isn't, right? Because 5 minus 0 is still 0. And so, it's still 5. And so I don't need to write this minus 0 part here. I could just leave it as x squared. The same thing applies for this minus 0. I could leave that as y squared. And the r squared just drops down. This is the equation we could use specifically when we're at the center at the origin. Otherwise, we should use the standard form equation. However, like I said, the standard form equation will work in all cases. It just might lead to a little bit extra work like it did here. With that, let's go ahead and try out examples number 1 and 2. All right, let's do it. Example number 1. Now, I'm going to use the standard form equation for both of these, just for us to get used to it. Once we're used to it, we can go back to using the shortcut method. The standard form, x minus h squared plus y minus k squared equals the radius squared. Here, this is going to be my h and my k. And I have a radius of 6. Well, looks like I've got everything I need to just plug it in and do the math. So let's try it out. X minus my h value is 0 squared plus y minus my k value is 0 squared equals the radius of 6 squared. Now, just like we discussed above, this minus 0 and this minus 0 is extra. It's unnecessary, so we don't actually have to write it. We could leave it as x squared. This y has a minus 0 as well, so we could just leave this as y squared. Lastly, 6 squared is 6 times 6, which is 36. This is how we need to leave our answer. If we leave it like this form above, you haven't simplified and you'll only get about half credit, if any credit at all. You need to make sure you simplify your answer completely. If you feel confident in that, try out example 2 on your own. Pause the video. If you're not very confident, go ahead and keep playing and we'll go over it now. So, let's see what we have. We've got the center at HK, and this time we have a diameter of 32. I need the radius for my equation. So the question becomes, how do I go from diameter to radius? Well, if you remember, diameter is twice as big as the radius. So to go from diameter to radius, I need to divide by 2. And I get the radius is 16. With that, I have everything I need to plug in. So let's do it. X minus the h value is negative 2. So negative 2 squared plus y minus the k value is 5. So 5 squared equals the radius of 16 squared. Now, the last thing I got to do is clean this up a little bit. When we have a double negative like this, it's important that we recognize it becomes a plus. I like to connect the dashes like that to make one big plus sign. I'm going to rewrite that down here just for neatness sake. On this part, y minus 5, there's nothing to clean up here, so we're just going to drop that down. 16 squared is 16 times 16, which gets me 256. This is our final answer. Now, before we move on to number 3 and 4, I want to point something out. Look at the numbers we ended up with, 2 and negative 5, and the numbers we started with. See if you can find any correlation between the numbers we started with and the numbers we ended with. I'll give you a couple seconds to think about it. If you said or you noticed that the originals have been flipped in the sign, aka the negative 2 becomes a positive 2, and the positive 5 became a negative 5, you'd be correct. That's exactly what I'm trying to point out here. The reason that happens is because of the negative in the equation here and here. This negative takes that original value and flips the sign. Now, the reason that's important to notice is that here in a minute, on the back side of this paper, I'm not going to give you the key features. Instead, I'm going to give you the equation, and it's going to be your job to work backwards to find the key features. With that in mind, let's go ahead and move on to examples 3 and 4, but keep this in your back pocket. We're going to use it later. Example number 3. I have a picture of a circle, and my goal is going to be to create an equation. To do that, I need the key features. I need the center, and I need the radius. Well, luckily for us, the center is located here at the origin, 0, 0. The radius is just 2 boxes. Now, I'm going to take a brief pause and caution you against something. Lucky for us, the units we're moving by here are 1. The scale is 1. On the practice, there's a question like this that does not have a scale of 1. So be sure you pay attention to that and count by that number. For us, though, it's just 1, 2. My radius is going to be 2. Now, at this point, I'm okay with us using the shortcut formula. Remember, if I'm located at the origin, I can do x squared plus y squared equals the radius squared. So we just plug that in. X squared plus y squared equals the radius squared. And the only thing I got to clean up here is that 2 squared is equal to 4. If you feel confident in that, try out this next one. There is no scale, so you don't have to worry about counting by different numbers. We just count by ones. If you're not very confident, go ahead and keep watching. All right? We need to find the key features, the center and the radius. The center is located at 1, 2, 3 for the x value, and 1, 2. That's negative 2 because we went down for the y value. The radius, I'm going to count from my middle to the edge. That's 1, 2, 3, 4, 5. The radius is going to be 5. I've got everything I need at this point. This is my h and my k, and I've got my radius. Let's plug the stuff in. X minus, my h value is 3 squared, plus y minus, my k value is negative 2 squared, equals the radius squared. And let's do a little bit of cleaning up. This part here has nothing to clean up, but over here we have a double negative. So let's fix that into a positive. Here, 5 squared is 5 times 5. And 5 times 5 is 25. If you tried this on your own and this is what you got, good job. If you went along with me and you still have questions, feel free to ask in class. Otherwise, let's move on to the back. Now, this is what I was talking about a moment ago. I give you the equation, and we need to find the key features so we can graph it. So I'm going to need the center and the radius. Now, remember what I said. We're going to take these numbers here, and for the center, flip their signs back to the original. So instead of a negative 4, we're going to be putting a positive 4 for the x value. Instead of a positive 2, we're going to be putting a negative 2 for the y value. This is where my center is located, at 1, 2, 3, 4, negative 1, 2. As for the radius, in the original equation, this part is r squared, correct? Right now, it's equal to 36. We can solve for r by taking the square root of each side. The square and the square root cancel each other out, leaving me with r. The square root of 36 is 6, so my radius here is going to be 6. I've got everything I need. Now all I've got to do is graph it. So in each direction, I'm going to go 6 out, 1, 2, 3, 4, 5, 6, and put a little mark there. That's going to indicate the edge of my circle. And I'm going to do that in all directions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now I can connect these with a smooth curve. Now, I say a smooth curve because if we connected it with a straight line, we'd end up with a shape like this, which is not a circle. Be sure when you're doing this, you remember, we are trying to make a circle. So we need to connect it with as smooth a curve as possible. If it still ends up looking a little bit pointy, that's okay. As long as I can tell your intent was to draw a circular shape, we're okay. If you feel confident in that, try out number 6 on your own. Otherwise, let's do it together. I need my center, and I need my radius. My center is going to be located at the opposite of this number and the opposite of this number. So instead of negative 6, I'm going to put a positive 6 here. Instead of a negative 3, I'm going to put a positive 3. So my center is at 1, 2, 3, 4, 5, 6, 1, 2, 3. And the radius is going to be located at the square root of whatever this number is. The square root of 16 is 4. So my radius is going to be 4. So from my center, I'm going to go 1, 2, 3, 4, and make a little mark. 1, 2, 3, 4, make a little mark. 1, 2, 3, 4, make a little mark. 1, 2, 3, 4, make a little mark. And then again, make sure you connect it with as curved a line as possible. We're trying to make a circle, not a diamond. And that is all about how you graph circles. If you have any questions, feel free to ask me in class. And as a reminder, we do have a test coming up, I believe, next Tuesday. So, if you have any questions, bring it to me. Otherwise, I hope you have a great day. Thank you.